Okay, it's absolutely great to be here. I am the official Kaggle representative, Kaggle company representative for this presentation or for this event. We have a major Kaggle team meeting going on next week, so very few people were able to attend. And so I'm happy to be here. The event organizers actually contacted the Kaggle leadership, and they asked, could we get the smartest Kaggle employee to come give this presentation? But unfortunately, that person said no. So then the leadership said, the organizers asked the leadership, well, maybe we can get the wisest Kaggle employee to come speak. And unfortunately, that person said no also. So the organizers, they got a little bit nervous and they thought, oh, maybe we can get the best looking Kaggle employee to come speak at this. And at that point, I was very uncomfortable turning down the organizers 3 times in a row. So here I am. Actually, the truth is none of that is true. I work with an amazing team. One of the things that Kaggle values as a company is low ego. And I think that is really easy to do in this field because no matter how good we are, there's always these super grandmasters who are so smart and they're so clever and they do so well. And it's very easy for us to, keep our egos in check. So I'm going to talk about a topic that I think many of us probably struggle with, and that is how do you keep up in a field that is constantly changing all the time, right? We know we need to keep our skills fresh, but how do we do it? And before I start, I don't believe there's a right answer to this. So I'm going to share what I believe is right and the strategy and methodology that I use. And hopefully you'll be able to find a few things that are right for you. So during the recent Kaggle Days San Francisco event, we had Francois Hollet. So he is the creator of the Keras Deep Learning Framework. And he spoke, and he told an interesting story. He joined Kaggle and entered his first competition and was competing, and he wasn't doing very well. So he thought, well, maybe Kaggle's not for me. He forgot about Kaggle, just didn't do anything for a few weeks. And then all of a sudden, he got an email from Kaggle saying, congratulations, you've won. Most of us do not win the first Kaggle competition that we enter. In fact, most of us don't win any Kaggle competitions. So it's very abnormal what he shared. Most of us, I think when we join Kaggle, right, some of us are very, very skilled. They come maybe with an advanced degree in data science or machine learning. But a lot of us, like myself, come knowing almost nothing. So, I'm going to talk about some of the principles that will help us. And again, they're very applicable to me. I really hope they transfer to many of you. So I'm going to start to talk about my education and my career. And not because either one of those are particularly important, but I really want you to understand where I was as an individual when I joined Kaggle in my first Kaggle competition. So that's me a long time ago. I got my first computer in 1983. It was a Timex Sinclair 1000. You've never heard of it because they went out of business in like a year. It was the company Timex that makes the watches, and they wanted to get into computers, and it was an absolute disaster for them. And that computer that I got, that, by the way, that's not a Timex Sinclair, that's an Apple II that was my neighbor's that I used to go visit and use their computer. But my first computer had 2 kilobytes of RAM. 2 kilobytes of RAM, just to put things in perspective. And so I taught myself BASIC. I really enjoyed it, right? I wasn't necessarily very good, but I really enjoyed it. My high school taught a class in Pascal programming, probably maybe not super familiar to a lot of you. I enjoyed the class. So then I thought, well, what do I want to do for a career? And it turned out that everyone I knew was going into computers. And I was worried by the time I graduated from college, there'd be a flood of talent and all of the jobs would be taken. Right, of course, that was foolish because the industry took off faster than the demand pool, and still to this day, there are people in computer science, and there's a demand for the talent. So I thought, well, what should I study? I chose chemical engineering, and I chose it not because I knew anything about chemical engineering. I chose it because it sounded kind of cool, chemical engineering. Well, at least it sounded cool in 1987, so please don't judge me for that. So when I was in undergrad, I took a class in Fortran 77. I'm sure most of us have heard of Fortran, and again, I really liked it. I went on to get a master's. For part of my master's, I used Fortran to write a program to model the combustion of a coal particle as it burns, and I really enjoyed it. So I went on to get a Ph.D. in chemical engineering, and this time, 100% of my work was computational. So I did direct numerical simulations of turbulent, three-dimensional turbulent flow and the particle movement within that flow. Now, interestingly enough, I don't know if many of you know this, but Fortran originally, you had to start in the 7th column, right? So space, 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 and then you would start your statement. And things like line numbers and whatnot could go in the first 6, but that was a throwback to the old punch card days. And this was in the mid-90s. They came out with Fortran 90, and Fortran 90 no longer needed you to have to worry about indentation, which was really great, right? You could just write your program how you wanted. And I thought it was fantastic how it unshackled me from having to worry about indentation. Now, I also find it very ironic that in today's age, Guido von Rossum, who invented Python, has reshackled me to a programming language that cares about indentation. So one other point about this, again, just to give you an idea of how fast things change. So now we're a decade later, we're in the mid-90s, and I had an IBM workstation, and I had received a $10,000 grant for equipment for my research. And I spent that entire $10,000 to get a memory module for this workstation that was 256 megabytes of RAM, which was, you know, a very large RAM back then, but $10,000 for that. So things change. So I got my first job out of school. So everything up to then was great, loving life, loving programming, loving science, loving chemical engineering. And then I got a job in an industry that uses chemical engineering. It was the paper industry. And my job was to optimize air and drying systems for drying cardboard, right? We use cardboard, you know, they make it wet, it's got to be dried. And I can't say I really enjoyed it. You'd have to go and, so, you know, you can see this is a person. You'd have to go and stand up here and you'd have this long temperature measurement that you'd stick in there and measure the temperature of these dryer cans. Then you'd do the same thing with a humidity, and you would do it on every single one of those on the back and the front. It was hot, it was sweaty. It was not what I went to college for 9 years to do. So I decided to upgrade my career, and then I went into consumer products, making diapers, or nappies as they call in some part of the world, and slightly more glamorous, I suppose, but still not necessarily giving me the career fulfillment that I had always dreamed of. And by the way, the technology that goes into making diapers is actually pretty amazing. It's just not glamorous work. So now it's the early 2000s, and I am absolutely bored out of my mind with my work. It's just not exciting. I don't enjoy going to work. And my company offered a distance education catalog. And I was looking through there, and they had a course on computational intelligence. And that was 3 things. It was genetic algorithms, that was considered computational intelligence back then. Fuzzy logic, which was super hyped up at about that time. That, I don't know, does anyone use fuzzy logic anymore? Probably not. And neural networks. So I took this course. Now, this was pre-Coursera days. They actually physically mailed you DVDs, and you would watch the lectures, you know, on your television. You would do your homework, you would email the instructor. 2 weeks later, he'd email you back your grade. So that was the distance education that was back then. I really found it interesting this idea. So they taught a very early version of convolutional neural networks. They didn't work well. They were very narrow, they're very shallow. And we actually didn't program this. So we're still on Windows. So the instructor he emailed us a pre-compiled binary. We would run it on our Windows machine, which was probably a single core CPU back then, right? Even if it had more than one core, it was only using a single core. But we would try to train this thing. And the problem was these little pop can images. I should have put a picture. And I was blown away that a computer could recognize, was it a Diet Coke? Was it a Dr. Pepper? Was it a Sprite? I was really fascinated by that. The problem is once I tried to apply this technology to anything in the real world, so in consumer product manufacturing, they're taking pictures of every product that's being made to do some simple measurements and whatnot. I thought, well, maybe we could use neural networks for this. Could never get it to work. So I said, well, neural networks, interesting, but not useful. So, so then fast forward another 10 years, I'm still bored out of my mind at work, right? But hey, family's got to eat. And I stumbled across this challenge. It was the Merck Molecular Activity Challenge on a platform called Kaggle. It was fairly simple. All you had to do is predict the molecular activity of these molecules based on tens of thousands of molecular descriptors. And I've got a Ph.D. in chemical engineering. I'm really good at data analysis. Top prize was $25,000. So I thought to myself, this is going to be the easiest $25,000 I've ever made in my life, right? I was literally picking out the car I was going to buy. So the person who won that competition, does anyone know who that is? It's Jeff Hinton. So his research lab won the competition using deep neural networks. And as Maria said, I came in, there were 236 teams. I came in actually 23rd, but it was from the bottom. I came in 23rd from the bottom. And it wasn't because I wasn't trying. I was literally trying my hardest. And it was actually a wake-up. I mean, it was very demoralizing, but it was also a wake-up call because I realized there was all of these things that I had no idea, that I didn't know. So it was just this like window open into a whole new set of tools and technologies that I could learn. Fortunately, another thing happened in 2012. So you probably know Andrew Ng is speaking here. In 2012, Andrew Ng was a co-founder of Coursera. And I found his course on machine learning and took that course. And again, I was blown away that here we have a course that would literally have costed thousands of dollars for me to take. It's online, it's for free. So things were good for a while. Things were good because you could take that Coursera course, you could read the few papers that came out. Jeff Hinton came out with a few papers. But suddenly there was a problem. This is just a screenshot of Coursera today. And there are more data science and machine learning classes that any person here can take, even if it's full time. If you look at the number of machine learning archive papers that are published every year, you can't keep up. So on the one hand, we live in an amazing time where you can learn the things you need to like in my case, change my career or become good at Kaggle. On the other hand, it's too much and you can't keep up and it's information overload. So my question is, how do you know, given the fact that everyone here must keep up their data science skills and machine learning skills. We have to keep up on the one hand. On the other hand, there's too much to learn. So what do you do? So the question is, how do we keep up? This is probably the most important point to understand is you can't keep up with everything new in machine learning and data science. There are people who are deep learning experts who can't even keep up in the deep learning field. And once you recognize that, it kind of then reframes your mind to say, well, if I'm not going to learn everything, what can I learn and how do I learn it? So I'm going to give 3 guidelines, okay, on how you can continue learning, like if you're brand new, how you start your learning journey. If you're experienced, how you continue. And the 3 guidelines are be sensible, be smart, and be systematic. Now, I was thinking about branding these the 3 BS's of learning data science, but I'm not sure if that's the best branding. You can give me feedback if that's catchy enough. So be sensible. Okay. All right, I crashed and burned on my first Kaggle competition, and like I said, there was an enormous amount of things I had to learn. Number 1, my computer was terrible. It was 4 years old, had 8 gigabytes of RAM, and I realized if I want to compete, so I started upgrading my computer, more RAM, better CPU, more disk space, even more RAM, better CPU, new motherboard, right? So I started that race that many of us do. Okay, that got me kind of far. I was only using MATLAB and some proprietary software, neither of which you can actually use to win a Kaggle competition. And at least at the time, MATLAB wasn't the best tool. So I realized I've got to learn Python. So that was another big major learning step. The second competition I entered, I actually did okay. I came in 34th out of 950, 34th from the top this time. And I used logistic regression, not because it was the right tool. It was literally the only algorithm I knew in machine learning. So I used it, right? There may have been better ones. Let's see, I know who won. There's some people here I know who won that. I can't remember. I know there's some Grandmasters here that actually won that competition. So then I learned, you start seeing XGBoost. XGBoost is winning everything. So then you learn XGBoost. Now, deep learning, I was sure that deep learning was a hype, just like fuzzy logic, and I avoided learning deep learning. Over time, a year later, I realized, okay, this is going to take over the world. So I started learning it. Well, that required hardware, GPU. It required, I was using Windows, so I better go to Ubuntu Linux. Every time I made this shift, I felt dumb again. I felt stupid. I felt like I don't know what I'm doing because it was a huge learning curve. So when I say be sensible, I want you to recognize that if you start feeling good about yourself and how good you are, it's time to jump into something else and to kind of stretch yourself and feel a little bit intimidating again. And that's perfectly normal, and that's going to continue to happen. I would say anyone who wants to be successful in this area has to get used to feeling insecure about what they know and what they don't know. It happens to me all the time. I don't like when I say something and it's a mistake, or I argue a position and it's wrong. On the one hand. On the other hand, I'm actually glad because, right, it improves me and I get better. So be sensible. Set your expectations to something that's reasonable. So the next thing is be smart. And what this means is you have to build a learning plan for you. If you go to GitHub, all these people say, hey, a step-by-step learning plan. That might be okay. It's probably not for you, right? And the reason is we're all at different places. If you go through and somebody's learning plan that is a waste of time, too advanced, not advanced enough, you will not do well. So be smart. So here's what I recommend when you set a learning plan. Excuse me. So say a learning plan, say you have 5 hours a week to learn. All right, you say, all right, every week I'm going to spend 5 hours. This is how I would recommend doing it. Number one, and I was talking to Pavel earlier, he's very big on this. Strengthen your fundamentals. So that could be the fundamentals of linear algebra, the fundamentals of statistics. Those things don't change. For me, most of the time I spend in there is learning Python deeper, right? Learning the language. My favorite book to read and reread is called Learning Python. It's this thick, takes me forever to get through. Every time they go a new edition, I start over again to refresh those fundamentals. The other piece of that is I spend a lot of time learning and relearning pandas. Every time there's a new edition, I learn what's new, and I also scan the API for things that, oh, maybe I didn't realize there was something cool there. So strengthen the fundamentals of whatever you need to learn. The second big chunk is your core work and your core tools. So this is whatever you're doing for your project, your problem, the work you do at work. For me as a Kaggle data scientist, a huge amount of that is domain knowledge. So somebody comes to us and says, we want to host a competition on earthquake signals. I've got to spend time learning about that so I can understand, I can ask the right questions. When Kaggle was acquired by Google, all of a sudden we were using our local machines, now we're using GCP VMs, right? So learning kind of that system stuff. I hate to bring this up, but we constantly also try to learn the new ways that leakage can enter the data, because there's so many thousands and thousands of ways, insidious ways for leakage to go, and trying to build our systems around how to minimize that. That will be different from every one of you. And then the last is spending time on the cutting edge. Now, this is where most people make the biggest mistake when they try to keep up with the industry. They spend way too much time because there's all this cool stuff. There's capsule networks for neural networks, or you know, the ordinary differential equation neural network stuff that was from the NeurIPS conference. So some really cool things. And I am not dissuading anyone from keeping up on those, but if you spend the majority of your time learning those and trying to keep up the speed, you'll actually be sub-optimizing what's critical for you. There are many tools that are going to come out that you'll be able to use right out of the box, like BERT, the NLP tool that Google, pre-trained model that Google released, right? That's something that is cutting edge, and you should be able to pull it right back into your, you know, your tool set. So that's approximate. You know, I would say you don't necessarily need to balance that on a week-to-week basis, but over the long term, try to balance that. One other point, when it comes to learning new things, I strongly believe that if you're not writing code and trying it out, you're not actually learning it. So I fall into this trap. I watch a lot of YouTube videos. Like when PyCon comes out, I like to watch as many of the PyCon videos as possible. And unfortunately, most of the time, I'm not actually implementing anything. I watch it, I go, oh yeah, that's a great idea. And then I promptly forget it. So if you see something that's important, make it a project and get it into your repertoire. So the last BS is be systematic. And this is the secret to sustainability. This is how you can do this in the long term and not 2 years from now go, oh man, I haven't kept up. So what do I mean by be systematic? I am a big fan of simple checklists. And some of you may have read, many years ago I wrote a post, it was my most popular forum post on Kaggle, where I said, here's my standard work that I do for every competition. And it literally is, I update my Conda environment. You know, whatever. So I do any environment updates. I create a new repo. I download the data. You know, so it's just this very simple checklist of things I do. So I use multiple machines. So I make sure everything's synced on all those machines. It wasn't anything that was complicated, but the reason I use checklists is because it reduces cognitive friction. When you're like, oh, especially with Kaggle, we're like, oh, it's really late. I really want to start this competition. You don't want to have to think about it. So having a checklist allows you to go boom, 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 and do it without having to think. Pilots use checklists. Pilots are some of the most skilled practitioners about what they do and the amount of training they have to go through. They use checklists because it reduces cognitive friction. If they have a headache, if they're tired, it makes sure they do the appropriate things. So, how do you use a checklist or a system when you're learning? For me, I have a list of things that I do every day to keep my learning up to date. The first thing is super simple. I have a bookmark bar for 5 different archives. So archive, the paper repository, archive topics, fluid dynamics, data and statistics, vision and machine learning, and earth sciences. I open those up and every morning, literally before I do anything, before I check email, I check what those are. So that's one of the things I do. It's a habit, it's sustainable. The other thing I do is, anytime that any of the PyData, the PyCon videos come out, I make a list of all the ones I want to watch, and I don't get to more than 10% of them, but I make the list, and then I work through them systematically until the next ones come out. All right, so if you want, so as I mentioned, there are so many courses, it's actually intimidating. Where do you start? What's the right course? I have become a big fan of Kaggle Learn, not because it's put out by Kaggle, because I really actually agree with the philosophy. What Kaggle, so if you think of a MOOC, if the time to make the presentation, to record the presentation, to transcribe the presentation, to host the presentation is a very, 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 very long time scale. What Learn has done is say, we're going to take some very key important topics and we are going to let you do it in 4 hours. And we're going to focus on those key important things and get you pushing the buttons and learning these things. What's nice about this, there's no video. Actually, one of the courses has videos, but they're going to get rid of them. Is they can freshen them. Like as much as once a week, somebody will ask a question and they'll realize, oh, we can make this better. So they'll refresh the content. So for example, if you look at this, so it's kind of small, but here's the current Kaggle Learn. Everything from Python, machine learning, data visualization, SQL, micro challenges, and the new one, machine learning explainability. Maybe you know those things, but maybe you want a refresher. It's really, really fun and easy to go through. So I'd recommend checking out one. So here's like this one on embeddings. I went through it before. I had never gone through. I went through it yesterday, and I thought, it was, oh yeah, it makes a lot of sense. So Kaggle Learn, great place. If you ever feel lost, go back to Kaggle Learn. Obviously, there's tons of great stuff out there, but if you're ever paralyzed about where you should go, go to Kaggle Learn. This is an example, right? So they walk through with words, they give you some code, you run it, it kind of lets you know if you were wrong, it gives you hints on the common errors, and it's fun, it's interactive. It's in Kaggle kernel, so you can access it anywhere, and now it actually keeps track of your progress. So, you know, if you stop one halfway through, it'll tell you which modules you've done. All right, the other thing that this kind of surprised me, if you go to youtube.com/Kaggle, there is an amazing amount of content, and it's added to weekly. Everything from coffee chats to interviews, for example, practitioners at Google Brain, all sorts of, so live coding gets recorded there. So this is another great example of a place you can start. There's probably too much content there for you to keep up on, and that's okay, right? Again, give yourself the permission to skip things and focus. Along those lines, there's a point I wanted to make. Every Kaggle competition that I joined, my primary goal was to learn something new. So embeddings, for example, I'm not an NLP expert. So if I join a Kaggle, I did a playground. It was spooky author. So it was like 3 authors, given a sentence, predict which one. So I did that with the sole goal to learn NLP. You know, you may enter one to learn, okay, finally I'm going to learn convolutional neural networks or LSTMs or some sort of, you know, whatever you need to go. So if you do that, no matter where you place, you will have won, you will have had time well spent. So I want to close up a little bit with this quote. It is by far my favorite quote. It's a little bit intense, so I want to explain it. It says, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. 100 years ago, so many people didn't know how to read and write, and that prevented them from being in the workplace. In today's world, not just in data science and machine learning, but almost any vocation, you have to learn, you have to be able to learn, to unlearn, and to relearn. So that to me is the most important reason for having yourself a smart plan that's sensible, that's smart, and that's sustainable, so that you can learn whatever skills and do that 5, 10, 20, 30 years from now to keep up and have whatever professional success that you want. And with that, thank you, and I'll open it up to questions. 1 second. Wrong headphone. Okay. Let's see who has the mic. Oh, there we are.
What?
Yes, I can hear you. Thank you.
Thank you for your time. So I'm asking regarding is any social courses for the learning data science for kids?
Oh, that's a great question. I'm sure there are, but I can't recommend any. And the reason being is that's not something I looked at. Does anyone here know of good data science for kids? I would say, I don't know for sure, but Khan Academy, Khan Academy, is one that has a lot of great content, but I don't know if they have data science. No? Okay. So, sorry, great question. I'm going to write that down and we'll follow up. Yes, sir.
Yes, hi, my name is Ali Samir. I'm working for Kaggle. The question that I've been trying to ask from many of the Kaggle Grandmasters, but I was able for some reason. I was busy on the other side of the island. Most of the real world data are messy. It's very messy. And in Kaggle, most of the data that we use are not that messy or perhaps very decent in terms of the quality, data quality. So my question would be is, when we are dealing with the messy data, for sure we can tackle or sort out some of the messiness of the data, but some of the messiness we cannot. Or maybe the cost of time and effort is too much that we just wanted to give up. So I would love to know that what type of the data that you just give up, what type of data you just wanted to spend some time.
Yeah,
Thank
that's a brilliant question, and I actually don't believe it's the type of data. I believe it's the volume of data, and what I mean by that is if your company wants to do a very large data project and you have data in multiple legacy databases that sit in multiple organizations, that can be extremely complex and hard to get. My recommendation is always to start with the smallest viable scope. So try to get a little bit of all the data if you can, or just get the data that seems the most reasonable and start doing model building on that. The biggest mistake companies make, and I've seen this many times, is they say, well, we're going to have a 2-year project to get all of the data collected. And then they get all the data collected and they don't have the signal that they need, or only 5% of that data was important. So I would say, just like it was mentioned by Grandmasters, when you're model building, you go quick, you go small, you go fast, and then go from there. I'd say the same with data. So then you may say, there's some very expensive data here that it's worth the time cleaning up, and it's worth the expense. But then you'll find data over here that's not worth the time. Again, the biggest mistake is companies say, well, let's clean up all of our data, and that's just wasted time. Thank you.
Question over here.
Yeah.
Trick question. It's gonna take you back to your fluid dynamics days. Navier-Stokes, you see, or the CFD computational models. You see a way neural networks, deep learning, all of those new fancy computational models can help in CFD and Navier-Stokes equation?
Absolutely, yes. And the reason is because Navier-Stokes is a 3-dimensional coupled nonlinear equation. What neural networks theoretically can approximate any function. So neural networks can approximate the function. So I just read a paper last week sent to me by a professor in Germany, and so there's a type of flow where you have a temperature differential, and then you get these circulation patterns. And if you ever seen a close-up of the surface of the sun, you see these like pockets. That's what causes that. And what they did is they did very, very high-resolution simulations of this, and then they trained neural networks to identify, so segment the boundaries of this. Now, they get the same results of these expensive simulations, but it's orders of magnitude faster. And there's a paper that came out a couple of years ago where I think Google was a co-author where like a smoke plume, right, simulate that, but then use neural networks to approximate that. So now you can model those dynamics. So you will see more and more of that, but the answer is absolutely yes, and it's exciting work. I'll say another thing, you're seeing more of this in chemical kinetics. So chemical kinetics, when you have multiple chemicals, it's it's a stiff nonlinear differential equations because you have very fast reactions, very slow, and people are now using neural networks. If you have this system of chemicals, can we model how they react? So we'll see more of that. Yes. So,
one of my questions is related to deep learning. Is it okay to ask the deep learning question?
I am not a deep learning expert, but I can.
Perhaps because you never, Kaggle never had a competition for deep learning. For the Kaggler, they ever use the deep learning model, like multiple neural networks.
But what was the? I missed the question because our neighbors are noisy.
Yes, my question is. When you have a limited data, like if you have 1 million picture, which is fine, but if you have only 100 pictures, so how can you do the training of the deep learning model?
So great question. So I'll answer that generally first. So in general, you want to pick the tool that's appropriate. There's no reason to do a very fancy gradient boosted. If you have a small amount of data and you can do logistic regression, then it works fine. So I'm a big fan of doing the simplest tool. Now with neural networks, we have the advantage of transfer learning, where Google has spent a month training a bank of GPUs on these large networks. And so you can use those, and actually probably not 100, but maybe 1,000 images, because you have all of this pre-trained models. So, something like that, I always say try it, right? If you have 1,000 images, kind of fine tune a pre-trained model on 500, see how well it does on the other 500. It's going to be very context dependent, I think. There's some image tasks that are extremely complicated that wouldn't work, but there's some simple ones that probably would work. Thank you.
Yeah, can you hear me?
Thank you.
Yeah, so I had a question. Since last lecture, the way you've shown where you have learned computer data science part, for the last 20 years, technology has changed exponentially. From now, I have been even working into deep learning part, and for me, it's impossible to think something out of the box. What next after deep learning? So, what according to you, from 10 years from now, which other technologies will be taking over? Data science in the industries kind of approaching it now. So, what's next going to be?
Yeah, that's a great question, and to be very frank, I am very bad at predicting what's next. I've always seen what's happening and then act upon that. There's a lot of people that talk about these things, and I don't pay a lot of attention to them. To be fair, I just watch for tools that I can use in my work. I will say this, data science, machine learning, AI. It's not going away in 10 years. It's not going away in 20 years. I think it's a fantastic field to be in. So again, it's the people that are willing to keep up and whatever happens to be important and learn that, I think are going to do very well for themselves. But again, I would be, if I knew the answer to that, I'd be on the main stage instead of this stage. I think we have maybe time for one more question, Maria?
Yes, and then we'll start our afternoon break, so we have 3 up to 4 minutes. Do you have any more questions? Yeah.
Hello. I think it's good that any suggestion how to help the others to become intelligent and start
So if I understand your question, is how do we help those who maybe are discouraged along the path? Yeah, that's a hard question. So I came to Kaggle with a Ph.D. in chemical engineering and a good career, and I remember the sense of being very intimidated to ask anything on the forums, right? I felt I wasn't worthy. I felt it was a stupid question, that everyone knows it but me. I think the more that we tell those stories to people, that's natural, that's okay, everyone goes through that, I think the better, right? That's why I'm happy to tell my story, how poorly I did. I tell my story of how frightening it was to ask a question on Kaggle. But we can also do a good job, I think. So Kaggle, we try to monitor the forums, and I can't say that I do this all the time, but if I see somebody that, you know, they're new and they're trying to say, hey, I'm new to this, you know, I as much as possible try to point them to, hey, just keep at it, don't get discouraged. So, you know, every one of you here can do that. You don't have to feel like you're a grandmaster to give people encouragement. So I really appreciated that question. And regardless of where your level is, I think you have the opportunity to do that. And again, that's what makes Kaggle a wonderful community. I love the Kaggle forums. There's so much useful content. People, you can tell, enjoy each other. A month ago is actually when I met my first Kaggler. I had never met somebody from Kaggle, but I feel like I know them just by the online interaction. So it's a wonderful place. And we just have to convince people that they can feel at home and themselves. Thank you for that.
Okay, do you want to ask any more questions? Okay, Pavel, I can see your hand. What is? Thank you, but it will be the last question.
I have a question. Who's your favorite grandmaster?
Oh!
No, jokes aside, do you have a person who you admire his style of, you know, thinking or something like this?
That's a trick question, right there. My favorite. So, probably he's maybe not as well known, but Farron from Germany, Matthias Müller. I liked him because I teamed up with him. He was always very helpful. He was always very friendly. He explained things that were easy way for me to understand. But you know, to be fair, there's so many Kagglers, Grandmasters, that I appreciate for all different reasons. Like Abhishek. I mean, he's just such an interesting character, funny guy. Has a lot to teach people. Yeah, and I can go through the list, but I'd say Farron Matthias Müller from Germany, now in the Bay Area, but actually maybe back in Germany. Anyway, he's my favorite. Yeah.
Back in Germany.
Thank you for that question.
Okay, thank you very much. Thank you, Walter. Yeah, it was great.